Did you know that salmon possess a remarkable homing instinct, allowing them to migrate thousands of miles across oceans and rivers, only to return to the exact spot where they were born? This phenomenal sense of navigation has fascinated humans for centuries. In this video, we'll explore the entire journey of salmon farming, from the collection of eggs under controlled conditions to sophisticated processing methods that ensure high-quality fillets. You'll learn how modern farms raise salmon responsibly, how salmon eggs are harvested, and how cutting-edge technology has transformed the aquaculture industry. Whether you're a fan of salmon sushi, grilled fillets, or simply intrigued by the science of fish farming, stick around to discover the fascinating path that salmon take from egg to plate. Salmon are anadromous fish, meaning they hatch in freshwater, mature in saltwater, and often return to the same freshwater source to spawn. This migratory journey is integral to their survival and reproduction. During migration, salmon display extraordinary endurance, swimming against powerful currents and navigating natural obstacles. Some species can travel thousands of miles to reach their native rivers or streams, a fact that continues to amaze researchers and marine biologists. Their life cycle consists of multiple stages: egg, alevin, larval stage, fry, par, smolt, adult, and spawner. Each phase is distinctly unique in terms of the fish's habitat, appearance, and physical demand. Understanding these stages helps us appreciate the intricacies involved in salmon farming, where the early developmental periods are closely monitored and controlled to ensure a healthy yield. The journey to responsibly farm salmon begins long before the fish are even visible. It starts with breeding and egg collection. In modern aquaculture facilities, adult salmon are carefully selected for their strong genetics and overall health. The eggs and milt, sperm, are harvested under strict oversight, ensuring minimal stress on the fish. The fertilization process typically takes place in specialized containers or tanks. The eggs are gently mixed with the milt in a controlled setting, reducing the likelihood of contamination or external stressors. Water temperature and oxygen levels are carefully maintained, creating the perfect environment for fertilization to occur. After this, the eggs are transferred to hatcheries, where they will remain until they are ready to hatch. By handling the fertilization process in these monitored conditions, farmers can boost survival rates and ensure a robust new generation of salmon. Once fertilized, salmon eggs are placed in incubation trays or specialized hatchery tanks. These environments are regulated to maintain ideal water quality. The exact incubation period can vary from 4 to 12 weeks, depending on the species of salmon and local conditions such as water temperature. During this critical stage, farmers minimize disturbance to the developing embryos while keeping water oxygenated and free from harmful bacteria. Eventually, the eggs hatch into alevins. At this stage, each tiny fish is still attached to a nutrient-rich yolk sac. The yolk sac supplies vital nutrients like proteins and fats that the alevin needs to continue growing. Since the alevins stay close to their hatching spots, farmers monitor water flow and quality to guarantee healthy development. It's fascinating to note that alevins remain somewhat hidden among the gravel in natural environments, where they're shielded from predators. In hatcheries, efforts are made to replicate aspects of this natural shelter to keep them safe. As soon as the alevins absorb their yolk sacs, they become free-swimming fry. At this juncture, they rely on external food sources. Farmers typically feed fry specially formulated feed that contains balanced nutrients, including protein, vitamins, and minerals. The feed is carefully measured and delivered at intervals to ensure steady growth without overfeeding. During this phase, the fry experience rapid development. Their fins become more defined, and unique markings or stripes, often called par marks, appear on their bodies. This is a visual cue of healthy progression. The fry are then transferred from smaller hatchery tanks to larger rearing tanks or raceways, giving them ample space to swim and exercise. Constant monitoring of water parameters such as temperature, oxygen concentration, and pH levels is crucial because any imbalance can hinder the fish's growth or lead to disease outbreaks. One major leap in salmon farming is the integration of sea cages paired with Internet of Things, IoT technologies. After the young salmon develop sufficiently, they are moved to these specialized netted enclosures in coastal areas, where the seawater flow offers a cleaner, more oxygen-rich environment. Sea cages can vary in size, but they're designed to give salmon enough space to move freely, mimicking some aspects of their natural habitat. IoT technology allows farmers to remotely monitor conditions within each cage. Sensors measure key metrics like temperature, salinity, dissolved oxygen, and pH levels around the clock. This data is transmitted to central control systems, enabling real-time decision-making. If a drastic shift in temperature is detected, for instance, adjustments can be made immediately to aeration or feeding schedules. The health of the salmon is paramount to any successful farming operation. Modern sea cage systems often utilize underwater cameras and video analytics to keep a constant watch on fish behavior. These cameras can detect signs of distress such as abnormal swimming patterns, visible wounds, or unusual clustering at the surface. When problems are identified, farmers can quickly deploy interventions, whether it's adjusting feeding times, isolating sick fish, or temporarily relocating the stock. Early detection is crucial because diseases can spread rapidly in dense populations. By spotting health issues early, farmers minimize the need for harsh treatments and ensure a more humane approach. Additionally, routine checkups by veterinarians help confirm that the salmon are growing at the expected rate and that health parameters remain stable. One of the biggest challenges in salmon aquaculture is perfecting the feeding routine. Feeding too little results in undernourished fish, while overfeeding leads to waste accumulation and potential water pollution. Advanced AI-driven systems address these issues effectively. By analyzing real-time video and sensor data, these algorithms determine when fish are actively feeding. Once fish lose interest in food, the system automatically stops feed distribution. This data-driven approach conserves resources and helps maintain clean water conditions. In addition, because the feeding process is optimized, salmon can reach market weight more quickly. Improved feed efficiency also reduces overall costs, benefiting farmers and, in many cases, consumers. Beyond controlling feed and spotting illnesses, IoT devices and automated systems offer numerous advantages for salmon farming. They help lower the impact on surrounding ecosystems by reducing feed waste and chemical usage. Sensors can detect changes in water quality before they escalate, allowing farmers to adapt swiftly and prevent pollution. Over the long term, these technologies reduce operational costs and labor demands while enhancing salmon welfare. Moreover, automation and data analytics help build consumer trust. Many operations now share detailed tracking information about their salmon, from egg origin to packaging details. This transparency is reassuring for customers concerned about sustainability and food safety. The entire cycle, from the hatchery to the harvesting stage, becomes more traceable and verifiable. When the salmon reach their target weight, it's time for harvest. The process begins with drawing the fish into specially designed nets or pumps. This step is conducted as humanely as possible, with minimal handling to reduce stress. Once harvested, the salmon are placed in well-insulated transport containers or tanks that maintain low temperatures and sufficient oxygen levels. Efficient transportation is crucial for preserving the fish's quality. In a matter of hours, the salmon are delivered to processing plants. Any delays during transit can degrade freshness and texture. Thus, the journey from sea cages to the factory is meticulously planned. At this stage, workers conduct initial inspections to verify that the fish are healthy and have been handled properly. They also confirm that the correct quantity and size of salmon have been delivered. Factories often have automated pre-processing lines that rinse and sort the salmon before further steps. This closed-loop system provides a continuous flow, optimizing efficiency and preventing cross-contamination. By the time salmon proceed down the line, they are uniformly chilled and ready for more detailed preparation steps. Salmon processing can involve both manual and automated tasks. Workers with expert knife skills typically remove the head, as precision is required to keep the best yield from the fillet area. Meanwhile, specialized machines quickly trim off the tail. This division of labor ensures efficiency and consistency while reducing the possibility of human error. Next, the fish are split into 2 fillets, removing the larger backbone in the process. Sophisticated machinery helps guide precision cuts, ensuring minimal waste. Many processors also collect the remaining skeletal frames for fish meal or other byproducts, supporting a zero-waste philosophy in modern aquaculture. Even after the main backbone is extracted, tiny pin bones can still be embedded in the fillets. To address this, advanced machines use sensors or X-ray technology to detect and remove these smaller bones. The machines carefully pull the bones out without tearing the flesh, maintaining the fillet's integrity and freshness. In some facilities, trained workers double-check fillets manually, ensuring not a single bone is left behind. This level of detail is vital because salmon is popular for raw preparations like sushi and sashimi, which demand utmost care in bone removal. The goal is to deliver a high-quality, boneless product that meets consumer expectations around safety and convenience. Once the fillets are boneless, they move on to an edging conveyor, where any uneven edges are neatly trimmed. This step not only improves the visual appeal, but also ensures portion consistency for retailers and restaurants. The trimmings can still be repurposed for other products, such as fish cakes or pet food, minimizing overall waste. After edging, quality control inspectors examine each fillet, looking for any inconsistencies in color, texture, or residual bones. A thorough final check ensures that only top-quality fillets advance to packaging. Vacuum sealing is commonly used to lock in freshness, remove excess air, and prolong shelf life. After the sealing process, the fillets are quickly chilled or flash frozen, then stored in a cold environment until they're ready for distribution. Salmon is revered for its delicate flavor and firm, buttery texture. From traditional Japanese dishes like sashimi and sushi, to Western-style pan-seared steaks and hearty chowders, salmon finds its way into culinary traditions across the globe. It's also a favored choice for barbecues, smoked preparations, and even raw appetizers. Restaurants appreciate salmon's versatility, while home cooks love how quickly it can be prepared with minimal fuss. Beyond taste, salmon offers substantial health benefits. It's a fantastic source of high-quality protein, rich in omega-3 fatty acids that support heart health and cognitive function. Omega-3s are also linked to improved mood, joint health, and overall immune response. Salmon is packed with vitamins and minerals like vitamin D, vitamin B12, and selenium, all essential for maintaining a balanced diet. Including salmon in your meals can contribute to a healthier lifestyle, making it both delicious and nutritionally dense. As demand for salmon continues to rise, sustainability is becoming a central focus of modern aquaculture. Well-managed salmon farms work to reduce their environmental impact through responsible feeding practices, improved cage designs, and continual monitoring of water quality. Some farming operations also explore alternative protein sources in feed, such as insect-based meal or algae oil, aiming to lessen reliance on wild fish stocks. Innovations in land-based recirculating aquaculture systems, RAS, present another potential future for salmon farming. These closed systems allow for controlled water conditions while minimizing the risk of disease and environmental pollution. Although still developing, land-based farming could play a major role in meeting the global demand for salmon without overtaxing coastal ecosystems. Whichever direction the industry takes, the combination of technological advancements, environmental stewardship, and responsible management practices will shape salmon farming for years to come. From their fascinating ability to migrate back to their birthplace to the high-tech systems used in modern aquaculture, salmon truly occupy a special place in both nature and on our dinner tables. We've explored each step of the farming process, from harvesting eggs in controlled conditions to nurturing fry in hatcheries, then moving them to sea cages outfitted with IoT technology that provides continuous data on their environment. The journey concludes with precise processing methods that remove bones and package fresh fillets for markets and restaurants around the world. Salmon's popularity isn't just about its taste. Its robust nutritional profile delivers critical nutrients that support heart and brain health, among other benefits. As technology continues to evolve, we can look forward to even more efficient, eco-friendly systems for raising salmon, ensuring we can enjoy this delicious fish for generations to come. Thank you for watching and learning about the intricate process of salmon farming. Don't forget to check out the rest of our channel for more fascinating behind-the-scenes looks at how food travels from farm to plate. If you found this video informative, be sure to leave a like, comment, or subscribe to stay updated on our latest content. We appreciate your support and look forward to sharing more exciting videos with you soon.